Hey, PerfBytes listeners, before you get started on today's episode, we'd like to mention the generous support of our sponsor, Flood.io. Imagine your load test plan runs great with just 10 threads, but now you need 100,000 users. Distributed load testing seems like a good idea, right? But now you're wrestling with out-of-memory errors and blocked RMI ports, and your load generators outnumber the target servers for JMeter. You are throwing knives in the dark with limited feedback and Mandralic reporting. Say hello to Flood.io. Launch Flood test using JMeter or Gatling, view and share test results in real time, scale out your own grid across the globe in minutes. Flood.io, distributed load testing for everyone.
It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day. Don't book like PerfBytes. Waffles, microwave ready. Blobbity blah, blobbity blah.
Add nutritional value to your brain.
It's time for PerfBytes with your hosts Mark Tomlinson and James Pulley. PerfBytes. Whatever.
Hey, it's time for PerfBytes with your veritably normalized hosts, Mark Tomlinson and James Pulley. James, how are you?
Mark, we're not doing the database show.
We're not doing the database show? Why?
Well, you said normalized.
Oh, sorry. There was another episode that was database performance. That's right.
Yeah. But to your question, I'm feeling better.
That's good. So you're feeling.
Yeah, but this L3 Martha strain of the cold.
Yes.
It knocks you on your butt.
I hope you're continuing to feel better. Welcome everyone to yet another episode of PerfBytes. We never say our slogan at the beginning of the show. Well, you're listening to PerfBytes. What's our slogan?
Helping to improve performance practices.
Helping IT professionals to improve performance practices. Helping IT professionals to improve performance practices. And so if you're listening to this and you are an IT professional, guess what? You have no choice but to have your performance practices improved. Before we get rolling with today's topic, which is a tricky, interesting thing when it comes to recording scripts and really difficult load testing things, we'll give a shout out again to continuing sponsorship from Tim Koopmans and the guys at Flood.io. Thanks for that. And Ubic, Philippe at Ubic Load, you'll notice on the website there's some web ads running for Ubic, another JMeter cool set of plugins and stuff. So anyway.
So Mark, what is our topic of the day?
Our topic today is dynamic data correlation, which of course begs the question, James, why is data dynamic in the first place, my friend?
Well, how long do we have, Mark?
It's upsetting. The question's upsetting.
Data is dynamic for a number of different reasons. One is you look at all the different computers that are connected, and we need to have some amount of uniqueness associated with each one of these connections so the server can discriminate one from the other on what data to send back. So that's one reason why it's dynamic. And the second reason at its core is because not everybody engages in exactly the same behavior. If you're in a call center and you call and you're doing account lookups for somebody on the phone because they don't know their account number, I'll call in, they'll be looking up last name Pulley, living in North Carolina. You'll call in, they'll be looking up last name Tomlinson, living in Pennsylvania. And so all of this dynamic data flows through the system. And as performance testers, we have to reproduce this beautiful melange of dynamic data.
It's a beautiful thing, but the world is dynamic.
Yes.
I mean, not everyone is named James logging into the system. One of the first things you do whenever you're building a load testing script is you are definitely going to randomize and parameterize. And even to get the script even working without doing randomization and parameterization, there's going to be simple things that are required just to get the script to replay. And for all of those of you who have never really gotten into load testing scripting, one of the main things is when you record at the transport level behind the GUI of a client. That we're talking basic SYNAC activity, send and receive in the WinSock world, or gets and posts in the HTTP web world. Maybe we could talk, James, about kind of what elements inside those payloads that get sent back and forth. What are the things that are actually dynamic? What are we correlating? What's in that payload?
It really comes down to a couple of or several different categories. Category one is anything that's related to session. So this is kind of a unique identifier for each of the clients coming in.
Right.
The second item is related to state. So this is kind of a record of your behavior that is being passed back and forth as a synchronization mechanism. Arguably, is to prevent someone from stealing your session and then reproducing your behavior, but it provides a nice, interesting challenge for us.
Right.
Then we have items related to time. Time is an easy element for a developer to grab, especially since the clock will go all the way down to the millisecond, and it's unlikely that someone else is doing exactly the same thing at exactly the same millisecond, so they can grab that one. And then finally, there is some dynamic data associated with that organic computing device located between keyboard and chair.
Which means human activity by its nature, no two people use an application the same as each other. And, a perfect example of this is there's a video out there from James Bach at TestBash who was talking about galumphing. He has this whole thing about galumphing, which is basically inherently exercising the freedom in randomness with an application. There's an elaborate reference he makes, and of course he turns it into galumphing, which is basically to say if you've got 100 people in the accounting department, they're all going to use the software slightly. One person uses a mouse, one person likes keyboards, and then if you have thousands of users in the real world, there's a huge diversity and randomness that needs to be represented from a human perspective. And really the tricky part is once you get a static script working, it's basically a static recording. So usually we start with a basic recording of a session. And when it comes to correlating the data within that single session, one of the nice things you get in a lot of the testing tools, LoadRunner has a great recording trace, Sosta has a recording trace, but there's other tools like Charles Proxy and Fiddler, as well as Wireshark that can show you raw cynic activity. And
but Mark, here's the core challenge. We have the ability to record. Yeah. But if you record once, how are you going to pick out what are the dynamic pieces?
Well, this is the best tip technique we have, which is you're actually going to record more than once and compare the different recordings. Now, you could keep in mind the test tools sometimes have a low-level recording trace, and then they also have a script that they would see that goes through in LoadRunner, you go through code generation. And if you're in Sosta, it has a really nice GUI that shows the different events and the different steps. But underneath the covers to compare recording 1 and do the exact same session, and do recording 2, take the exact same user, exact same steps, and then you would compare recording 1 to recording 2 and see what changed. Now, you're going to see what, as you pointed out, date and time, some of the system level things.
Exactly.
You're going to see session IDs, and we could see its state related things. So a view state and ASP state. If you're an old school ASP shop, you've got ASP view state, I guess is a form of that. And you're going to look also then sort of that a J session ID is a good example. And those are the kinds of the basics you have to look for in terms of being random. And then once you record again, how are you going to compare those? How do you compare those, James?
I generally just use a file comparison tool. WinDiff is pretty ubiquitous. It's been available as a downloadable tool for a long time. A lot of tools incorporate it, like LoadRunner incorporates it.
Yeah.
So when I'm looking at the comparison of the two recordings, I'm really looking for interesting elements or differences in the send items. Not necessarily the receives, because the receives are going to be fairly dynamic depending upon what you're querying. But I'm really interested in the sends because that is what I have to reproduce as dynamic data elements. Right. Then I have to determine, do I have all the dynamic data elements captured? And are some of these reproduced by local code? So if I can't find something that's been returned to me, odds are I'm going to have to look at a local algorithm.
Right.
So how do I track down all of the dynamic elements? And Mark, you and I just talked about recording twice. Unfortunately, we don't get to stop there.
No, we don't. You can actually do multiple recordings. Now, the first 2 recordings you should do to figure this stuff out, you should use the same login and do as close as possible the exact same steps. So the only thing that highlights as a difference between your comparison are those elements in the fields or the headers or even cookies that get sent back and forth. The idea being you want to do, for the first two recordings, start simple and do the exact same thing twice. And this can get really specific in the GUI, like don't go galumphing. in James Bach style. Do it very calculated the exact same way. But that third recording and fourth recording could be different, where you would just change one thing, like do the same business process, but log in as a different user. What would happen then, James?
Well, in that case, Mark, in the first example, we would actually see session state and time is what we would pick up as differences. As we change the user login, any dynamic information related to a user token or a security token that's tied to the user credentials would change at that point. So you'd be able to identify that element based upon a change from your previous recording.
Right. Don't go to a totally different business process with a totally different user. Try a different user, and then you're going to see maybe there are a couple more fields that are user specific, where some people have permissions to an extra field or two, and they get posted back differently. And correlation in the web is very field related. Mm-hmm. If you get into WinSock or even like ODBC or JDBC, you can actually have correlations there as well, and you need to pull data out into a parameter and then resubmit it as a parameter into the next SQL call or on a send and receive in the WinSock world, which kind of brings us to the next level of complexity. Once you vary things like the user ID and start trying a slight variation of the business process, my recommendation would be learn the correlation in the basic steps of the business process and then do the same steps and add a few more steps just to see what you learn and sort of incrementally grow to one larger business process. Don't just jump around. Kind of just incrementally grow what you're doing, because keep in mind, this is the learning curve. This is when you're studying the patterns of the send and receive information from the client in these recordings, you're really becoming a master and learning what those patterns are and when the fields change and things like that. I think once you change the business process and the data, then what else? What other fields are left to correlate?
Well, that's a great question, because if you've already identified session, state, time, user credentials, and any data which is variant for the business process, so you're running the same business process but maybe looking at different accounts as an example, anything that's dynamic which is left, guess where it comes from, Mark?
A single malt scotch?
Well, that may have been the inspiration for the developer who created it, yes.
I bet it comes dynamically from what the client is doing. And that could be either the human being putting random stuff into the client, or it could be code that gets executed through some kind of function that's no longer there. When we're running a virtual user with these scripts, the client could be a JavaScript or any other fat client. The client code is not executing. So my guess would be it's going to be in an algorithm running within the client that's no longer there, and you're just stuck with this static, what looks like a static value, right?
Or it's changing, but it's not being sent to you in that form.
Right.
For instance, you might be receiving the number 32, and it's going through some sort of algorithm, and it's coming out as the number 128.
Right.
And you need to find out what that algorithm is. So, Mark, to your point about the scotch, maybe you grab a bottle and go find your favorite developer and have a drink or two and find out where in this ugly child called code is this algorithm that produces this output.
Yes.
Hopefully they're not using some toolkit where they're 5 layers deep and they have no idea.
Yeah, that's the big thing now when you're on top of an Ajax toolkit or other frameworks. Developers are coding in an abstraction layer. They don't really know what's happening in these guts underneath. Let's get into some of the troubleshooting that we commonly do for data correlation, James. But first, let's take a second for a word from our sponsor, Newco. You remember those guys, right?
Yeah, I remember them.
Hosting for PerfBytes.com has been provided by Newco, New Centers of Excellence in Performance Engineering, PowerTest Professional Services, The Script Farm, LoadRunner by the Hour, Videratech, Cloud Architect, and No Load Test. For more information, go to www.newcoe.com or call 703-856-8187.
And we're back.
You're right. We're back. And now this is, James, before we talk about troubleshooting, I have to say right off the bat, this is the hardest part about doing load testing, I think, from a technical perspective. if you're a beginner, 99% of the time you're going to get stumped on correlation. We've even seen it with buddies like ours in Carlos, who's on some new version of Hyperion, I think it was.
Yes.
And he was like header correlation. He had a whole new smorgasbord of things he was learning. And so it's not, this is constantly, it's like comes with the craft of what we do, right? This data correlation is complex and it's hard, and you know what? But it's doable. It's not impossible. It's just difficult.
It's like the hacker security expert, relationship. It's the tester developer relationship. They're always trying to make our job more interesting.
Yes, of course. Sometimes they know they're doing that. Other times they're just innocent. So let's talk a little bit about what tips can help people to improve their approach to data correlation. The first one I wrote down here: understand your regular expressions. Go print out the cheat sheet for regular expressions, regex, and master it, because one of the key things within correlating this data that gets returned from the server is you're going to set up left and right boundaries. So the left boundary sets up where the search is going to begin, and then you're going to grab the data moving downwards, incrementing your pointer through the string to actually go grab then until you hit the right boundary. So you're going to correlate and pull that data out in an extraction from what's between the left and right boundary, and the left and the right boundaries can be regular expressions. And this gets very complex. And with more complexity in regular expressions comes CPU overhead. So be aware that if you become the regular expression master, and James, I don't know, what's your thoughts on this?
I'm not a big regular expressions guy, Mark.
Mm-hmm.
I'm admittedly. What I do is I just generally back up to the next constant or fixed point, either left or right boundary condition. And then I just use whatever string API to just cut up or cut out what I need. It takes me less time to do that than to figure out the correct regular expression to go and pull the thing out of whatever it is I'm searching for.
Right. But you agree that at certain times we do need, there are dynamic left and right boundaries that, knowing at least the basics, dot star, wildcard, kind of basic wildcards, you at least have to master that.
Oh, absolutely. Upper, lower case sensitivity, any number, any letter, those are the basics.
Yes.
If you get some of these more exotic ones, a T followed by an X, but sometimes Y, in this condition also a 6. It's like, oh, forget that. Just give me a big block, I'll cut it up myself.
Yeah, exactly. The other thing that I see people get stumped on is when they get their favorite recording tool and they sit down and they record it, and suddenly their trace file or the recording script actually is just filled with binary gobbledygook, which means it's usually encoded, or in some cases it could even be encrypted. If you're doing JSON testing, right, you've got a serialized object that comes back across the wire at you. Well, you don't really see the raw, clear text. And really, from understanding how to correlate and change values and parameterize values, you need to expand that. You need to deserialize it, you need to decode it, and of course maybe decrypt it in order to use that data or parameterize and correlate that data within the script. There's a couple of great functions. In LoadRunner, there's something called the data format extensions, but it's a tool that allows you to do this. And more of the testing tools, they sort of take care of this for you. In two ways. One, they either record at a higher level where they don't have to worry about the objects, but underneath the covers, that deserialization or decoding is happening. Or even if you're at the transport level in a raw kind of script, they give you the functions or they automatically do this sort of decoding for you. And the one thing I'll say to keep in mind is that after you see the clear text and you can update those data values and correlate them, don't forget that you need to re-encode that data or re-encrypt it and send it in the post. So James, this is you've seen this a lot even in the WinSock. I remember doing a lot of WinSock stuff years ago. This was pretty common, seeing things in hex and binary. And what other formats did you run into?
EPSIDIC, you do EPSIDIC to ASCII conversion. I know we probably shouldn't be saying that at the dinner hour, but, why not? And one of the things that really stumps people these days quite commonly on the web side of the house are files that are sent in zipped format or they're base 64 encoded. And a lot of this job is really about identifying patterns. As an end user of any tool, it would be worth your while to understand what are the common headers for common compression algorithms, or what base 64 looks like, so that when you see these things represented in your download stream, you can say, okay, that's LZH compression, that's PKZip compression, that's base 64 encoded. I know how to deal with that. Expect to see those things. And Mark, this kind of runs into our next issue, which is, kind of abut some of this, which is the issue of special characters in a left or right boundary condition.
Oh, yeah. So one thing that I find is as the IDEs evolve, right? And there's a whole new version of VUGen that came out, right? New IDE. You look at the GUI in JMeter, you look at even in the SOASTA GUI, they're loading those steps into quite the GUI. And sometimes those GUIs, they have limitations of their own in the fields to display these steps, and they may hide a blank character, a null character, a new line character, a carriage return, special characters, special ASCII format characters. If your GUI in the testing tool doesn't display them right, you might not see them, or you might assume that they're there, but they're not there. That can trip you up, where all of a sudden, and again, go back to that WinDiff to compare sort of a raw trace in Charles Proxy or in a Wireshark. Look for, all of a sudden you'll see there's some embedded character, and like Wireshark shows you the raw.
And Mark, the bane of my existence is the hidden tab character.
The hidden tab character. You can hardly see it. It's almost like non-blank space in the web, although we make it very, very obvious in HTML when you see non-blank space. So special characters can really throw you off. So again, going back to the diffs between these recording traces will help you out quite a bit. Another thing is dynamic boundaries. We talked about and solving those with regular expressions, but we also see with a framework, let's say in Java server faces, where you've got each row in a table, the ID is like J underscore ID 124, and then 125, 126, 127. Then it goes 224, 226, 227. Again, pattern recognition. And these IDs are changing, but it'll be like each row of data, and you have to correlate each field on each row of data in the screen. There's left boundary static, right boundary dynamic, then the right boundary of parameter 1 is used as the left boundary of parameter 2, and then the left boundary is dynamic of the right, and you get this static, dynamic, 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 static, weird chain of things that can just blow your mind. And you have to work through it, and again, look for the patterns in the data.
This is why this is not a $10 an hour job.
Yes, this is why pattern recognition, people who are really good at it, sometimes I wish I had sort of that mental brain of like Rain Man, be the Rain Man of data correlation, be able to definitely right boundary, dynamic, definitely a right boundary, dynamic route boundary.
Yeah. Yes, Mark.
You were speechless.
Yes. Well, we'll go for a drive later and then watch Judge Wapner.
Definitely, Judge Wapner wants to correlate the data for sure. So yeah, that's pretty good. I think what's a few other tips we have here? One is that the data that is rendered or in a script component that we mentioned, there could be this algorithm that creates data, and if, like, say, a JavaScript is not run by your test tool, it's just sort of downloaded and discarded, you may need to actually fire up a JS engine and render it on the fly. Or you may need to write your own code in C or Java or whatever language your tool uses to mimic what that algorithm does.
And what's really nice is almost all flow control is universal, whether it's C++, Java, C, VB, all the structured flow control. You should be able to pull from whatever algorithm generated the output and bring it straight over. You might have to deal with some items related to declarations, a little bit of error handling, but most of the algorithm you should just be able to lift and bring over. One of the most common client-side generated elements is really the use of the client-side clock for the 10 or 13-digit Unix timestamp, which is time since January 1st, 1970.
Oh, yeah.
It's built into most operating systems. It's really simple. Almost every performance tool has the ability to simply grab the clock in the correct format. But if you see a 10 or a 13-digit number beginning with 13, don't freak out. It's the clock. Just figure out if you need 10 or 13 digits.
Yeah. The other thing you might find is that you may load a DLL or a jar file or even the JavaScript file right directly into your test tool and actually run it. So, like in vusers in LoadRunner, you'd load something ANSI compatible with extern functions for DLLs. You could load those in. There's add-ins to Visual Studio and Java, so you could load a jar file and call a method within the jar file to actually render and do some work. But you're going to need the developer's help and maybe even a vendor's help to figure out how to do that. And again, that's why it's not as easy as it looks. James, what is this next one that you wrote down about the field names never being the same? What is this tip?
Never assume a field of the same name is going to be the same value throughout.
Yes.
Let us go to a universe where we have developers who really don't like testers. And in this universe, on every page, there is a variable of a name. We'll call the variable Mark.
Yes.
And every time you look at the variable on a new page, it has a different value. This is not a quantum variable called Mark.
No.
This is an example of usually a state management variable or some sort of security token which is passed back and forth that just has to be continually authenticated. One of the most common mistakes, particularly for immature users of tools, is they say, oh, I have this variable called Mark on every page. I'll grab it the first time I see it, and then I'll replace the same value everywhere.
Yeah.
That doesn't work. It'll blow up real fast,
Yep.
And then you'll be scratching your head and ask, why does Mark not love me?
Well, because that field might get updated on each exchange, so you need to refresh the correlation on each step instead of it getting stale. Which brings me to the other point, which is if you reuse those variables, be sure that you reuse the memory of those variables, right? So if you only really need a parameter or a variable once, don't roll unique variables and then chew up all the heap space and crash your load generator.
Oh, yeah.
I've seen that happen. And the most common one is probably view state. When you see view state get to 5, 6, I mean, view states can get huge.
Yeah, and then you get 20 or 30 exchanges, and all of a sudden you have a virtual user that's 150 to 200 megabytes in size, and you have 5,000 of them on a 2 gigabyte machine because that's what your CTO said you have to use, and it's a virtual machine as well, and it's shared with 15 other organizations, and all of a sudden it goes down and takes everyone else.
Whoa, James, you're overheating, dude. Just I know it's very difficult to handle that, my friend.
Sorry, I'm having flashbacks. I'm sorry.
You're having flashbacks. It's like PTSD from data correlation. So yeah, so those are some of the tips that we have, and you can see. Really, generally, this is what makes load test scripting really, really hard. And this is why when you look for a resource or look for somebody to help you, either learn how to do this or you're going to have them do it, this is why the interview questions have to go deep. And in the former episodes, we advise people, have them come in and sample test a script on your actual application. Don't just take their word for it. These correlations can throw off even the most seasoned veteran load testing person because new applications always come up with new frameworks and stuff. So this is the hard part, folks, and it's worth investing in the expertise in order to make it easy, as well as, to be honest, the guys in the corner office, this is all super techie gobbledygook, right? There's no real value that comes out of this effort except for the ability to actually have a functioning script and running the test. So it's a dangerous part in terms of technical complexity because it really goes off into the weeds, and it's hard for non-techies to understand this kind of stuff. But anyway, that's data correlation. James, any last thoughts?
Just be very mechanical in your approach. Don't be afraid to record multiple times. Use multiple sets of data. Watch for the changes. Record them. Expect that you're not going to be generating multiple scripts in a 4-hour window. You may have to set your management's expectations to a more realistic level to handle these dynamic elements.
Yeah, and if you're just starting with a new application you've never scripted before, give yourself an extra day just to incrementally start small and slowly learn the patterns within the data exchange till you can get it mastered, and then and slowly grow the scripts from there. But there we have it, James.
Well, listeners, you've come to the end of another thrilling episode of PerfBytes, and I feel emotionally fulfilled. What about you, Mark?
I think this is just the tip of the iceberg on data correlation. We could probably go deeper into this in the future. I, of course, want to give my post-Mexican vacation thanks to my to the sexy Irish voice of PerfBytes for bringing me rum punch and margaritas all last week.
And I want to say thank you to my mother for listening. I always appreciate her feedback. Thanks, Mom.
Thank you, James's mom. Of course, special thanks to our great sponsor of PerfBytes, continuing sponsor, Tim Koopmans, and the guys at Flood.io for their support of the PerfBytes listeners and the PerfBytes episodes. Thank you, guys.
And, of course, to our new sponsor, Philippe and the gang over at Ubik. And I just want to point out, Mark, that today's PerfBytes episode is powered by the number E, the mathematical constant. Not the letter, but the number.
And of course, keep in mind that all of the content of this PerfBytes episode and every PerfBytes episode is copyrighted and protected in the same way that the Mexican federales who are armed at every stop. I mean, some stops, they want to sell you the fruta, and then other stops, there's all the cops there with the guns, and they stare at you, and then they pass you by. So just think of PerfBytes content being protected by the federales.
And they want to understand if you have any contraband fruta.
Yeah, contraband fruta or a stray perforant. Think of it the same way, I guess.
For more information about PerfBytes and this show's episode, please visit our website at www.perfbytes.com or follow us on the Twitter or the Facebook. And of course, you can always subscribe and listen to PerfBytes podcast on iTunes. Just search for PerfBytes in the iTunes store and click subscribe.
Yes, and the PerfBytes show and staff are big supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, the Computer Measurement Group, the Workshop on Performance and Reliability, and of course, the Software Test Professionals community of software testers. And James and I really hope to see you at the next STPCon conference, which is held in April of this year, in a couple of months, in New Orleans.
Join us for bourbon, beignets, and beads.
And coffee at Café Du Monde.
Well, okay, I'm not a coffee drinker. And coffee.
Yes, exactly.
Yeah.
That'd be fun. And coffee, like you need more well caffeinated. All right, thanks everyone. We'll see you on the next PerfBytes.
Have a great week.